Inside Engineering, an introduction to the world of engineering. In this video, we will discuss civil engineering. Civil engineering includes the analyzing, designing, planning, building, and maintenance of facilities that serve people, such as office buildings, schools, hospitals, airports, roads, bridges, and dams. A concept frequently used in basic civil engineering is the free body diagram. In this example, the box's mass is 5 kilograms. This means that the weight of the box, or the force pushing down, is 49 newtons. This is reached by multiplying the mass of the box in kilograms by the pull of gravity's acceleration, which is 9.8 meters per second squared in a downward direction. This means that the force pushing up, or the normal force, is also 49 newtons, because the forces must be equal when they are in opposite directions, in order for the box not to fall through its surface. When a force is applied, as with someone pulling the box, it causes the box to move. However, there is also a frictional force that pulls in the opposite direction of the person pulling the box. With physics equations and knowing the force and angle that the box is being pulled by, the frictional forces can be calculated. The concentration of geotechnical engineering is concerned with the behavior of Earth's materials, usually below the surface, and how fault lines, soil types, and rock types could impact construction. For instance, geotechnical engineers would deal with problems such as sinkholes under roads and buildings. A geotechnical engineer would have to design a solution to the sinkhole and try to prevent further problems in the future. Structural engineering deals with the designing of framework for buildings, piping systems, and bridges to hold the required loads and forces. Transport engineering optimizes and maintains transport systems, most commonly highways, but also railways, shipping routes for UPS, underground transport, and airway travel. The concentration of water resource engineering manages natural and urban water systems, such as dams and sewage systems. Construction engineering manages construction by designing, planning, and executing building projects. Construction engineers estimate the costs for such projects and acquire the necessary materials and equipment. Construction engineer is also another name for a construction project manager who designs how a construction project will be handled. Architectural engineers design the engineering systems involved in buildings and look at the efficiency of these systems, as well as develop ways to preserve the structural integrity of buildings. These systems include structural systems, as well as electrical, lighting, heating, air conditioning, fire protection, and plumbing systems. George Washington was our first president, but he was also a surveying engineer. However, surveying tools have improved greatly since then, and surveyors now use a tool that looks like this. Surveying engineers measure and record the geographic elements of the Earth to help find land for building projects. All of the concentrations described in this video form the components of civil engineering. Most engineering schools offer civil engineering. Some of these schools include Georgia Tech, Stanford, University of California at Berkeley, the University of Illinois Urbana-Champaign, and the University of Texas, Austin. The world will always need more engineers because our world will never stop developing and innovating. So join the movement to improve the world. This video was brought to you by Inside Engineering.